Thank you everyone for taking the time to attend our webinar. Today we have got Sean with us. Sean is our technical sales engineer and he will be doing the demo. I'm Rohit. I'm VP of product marketing and I'll be setting Sean up, talking about how Access Server can provide zero trust access to your applications. If you have any questions, type it in the Q&A box and someone will respond to you either in the Q&A response or we can handle some of the questions live after the end of the webinar. But keep those questions coming in. They'll get answered. All right, with that, let's look at what the agenda is today. I'm going to do a brief introduction of OpenVPN. Then we are going to, again, very briefly touch on what Zero Trust is and introduce Access Server, talk about some of the Zero Trust features that Access Server has. I'm also going to share a few items that have been roadmapped that have to do with Zero Trust in the Access Server's roadmap. And then I'll hand it over to Sean for a demo of the Zero Trust features in action. So most of you probably know OpenVPN from our heritage and open source. We started as an open source project with OpenVPN protocol and the software that implements it. But for about 20 years or more, we have also been developing commercial VPN software and services for businesses. We have two products. One is the Access Server, which we are going to talk about today. The other one is a service offered through 30 plus points of presence all around the world. It's called Cloud Connexa, and you can think of it as VPN as a service, but with a lot of enhanced features. So it has built-in security features such as IDS, IPS, and domain name filtering, content filtering, web filtering. There are many names for it. And also very advanced routing features, application sharing features. So that's our cloud delivered offering. So you don't need to run your VPN servers. You just connect to one of our POPs. Both of these services have built-in zero trust features in them, and we will talk right now about what zero trust is and what are those features. So if you look at the slide on the left of it is the legacy VPN approach. So the VPN protocol is the same for both scenarios. Let's say it's OpenVPN. We need tunneling to connect the device to the network, but the trust approach here is different. So on the left-hand side is the moat and castle kind of approach in which you assume that everything within your castle is trustworthy and safe. So here, the castle is the campus network or the enterprise network. It's shown in green. The apps are there. The devices connected to the campus networks are deemed to be safe and can access the applications. And then outside of that is the big bad internet, which is shown in red. And the campus network is protected using a firewall. So that's kind of the legacy approach. And the firewall, many of the firewalls also have some VPN support in them. So here the device connects to the VPN in the firewall, does some basic authentication. Once it's given access to the campus network, again, this implicit trust based on the perimeter concept kicks in, and you say, okay, now this device is part of the campus network, so it gets access to the applications. So this is a simplistic view of the legacy VPN approach, um, where trust is granted based on where you're connected or on the perimeter. Trusting that there is a green zone, there is a red zone. If you're in the green zone, you're good. Whereas on the right-hand side is the zero trust VPN approach, in which it's not based on the perimeter. So, you know, everything is untrusted. It doesn't depend whether the device is connected to the campus network or not, whether it's in the internet. The location doesn't matter. Every time access to the application is requested, you verify that the device and the user requesting access is who they say they are, and you have policies in which, based on the identity, the user is given access to applications that they need for their role and not to everything. And then you also verify that the device is authorized, the device is safe, things like that. So that's what we call the zero trust VPN, in which VPN technology, VPN protocols are still used for access, but overlaid on that are zero trust controls. You probably might have heard that, oh, VPNs are bad, and replace it with the zero trust approach. It's more nuanced than that. It's how you implement your zero trust approach and zero trust principles. VPNs are still needed in order to tunnel the traffic and get access to private applications, but it needs to be implemented with zero trust principles in mind. So here are some points just to reiterate some of the things I mentioned. So zero trust means trust nothing, verify everything. Don't trust based on where it's connected or the type of device, etc. Always verify, provide access based on the user identity, context, give users only what they need access to. And the other thing is this verification process needs to be continuous and needs to take as many things as you possibly can into the decision making when applications are being accessed. So for example, device posture, location, some advanced behavioral analytics, whether the time of day matches with the normal pattern of the user, whether the applications being accessed by the user um, are in line with normal behavior, things of that nature. So here's a bit more detail on Access Server. So Access Server is our self-hosted software VPN solution. It runs on Linux, so you can install it on a variety of Linux distributions that's shown here. You can also deploy it as a virtual appliance. We have virtual appliances for ESXi and Hyper-V. and you can also use Docker. So it's compatible with Docker. We have an official Docker image. And then you can run Access Server in any of the cloud providers because it's basically being run on Linux. We also have listings in the marketplaces of all the major infrastructure as a service providers so that it's very easy to find and deploy in their environment. The other point is that we sell Access Server based on the number of VPN connections used simultaneously. So even small teams can start using it, and teams within the enterprise or the entire enterprise can use it because it's economical in the sense that you don't get charged per user. You are getting charged by the number of simultaneous connections. So even if there are 100 users, but 20 of them connect to AWS using Access Server at the same time, then you just need 20 connections. Access Server also has implemented in it data offload, data channel offload. We call it DCO. So what that does is it leverages the kernel to encrypt and decrypt and forward data packets, increasing the speed of the connections. Whereas, without it at the user plane or at the application level, all of the encryption, decryption, and the packet transfer takes place. With it, the kernel uses its power and multi-threading and all the benefits that come with it. And lastly, it's easy to manage using various portals. So the administrator has an administration interface, and the clients, it's very easy to distribute the connection profile and the client software to users because users also have their web interface. So users can log in to the Access Server. They see a page from which they can download the client. And for desktop applications, the client comes bundled with the profile. So they just open it and click connect. Point to note is that if you don't feel like hosting the Access Server, but you still want it within your trust domain, you want it on your network, but you want someone else to manage it for you, we have partners that can do that for you. So here's a slide which talks about the scalability and high availability of Access Server. So we call it Access Server clustering, in which multiple Access Server nodes, they don't need to be, they can be geographically separate too. They all share one central database so that all the certificates are stored in there. And then they can act as one huge access server, one huge logical access server, so that you can handle a lot of incoming connections as well as provide high availability. So even if one node crashes, the traffic can be shared among all the other active nodes. And we recommend to use DNS round robin. So that's a DNS record being shown up there to load balance the VPN connections among all the access server nodes. So let's talk about the zero trust controls of access server. So the first and the most important one is identity-based access. So what I mean by that is first you verify the identity of the user, and Access Server supports multiple authentication methods, Radius, LDAP, SAML. You can even do your own custom authentication. Plus, it has built-in support for Google Authenticator, MFA. Of course, if you use SAML, the MFA of the identity provider gets used. And then combine that identity with the access policies or ACLs, which act as keys. So if you think of, you know, imagine you have a big mansion and all the rooms in there, each room corresponding to different applications. You are going to give the guest the keys to just the applications or rooms that they can visit. So each guest user identity needs only those keys or only access to those applications that they need to use to get their work done. So that uh, once you implement that, that prevents lateral movement, that prevents an attacker, you know, um, getting access through some lost credentials or bypassing MFA and then trying to get access to apps for which that user wasn't authorized. So you limit your damage if you provide least privilege access. Then on top of that, you can have additional checks. So additional checks here can be, device identity. So you allow only authorized devices to connect. It can be based on location or IP address so that you allow only VPN connections from specific IP addresses to be established. And the way we implement these additional checks is by a mechanism called post-auth. It's a script-based mechanism. So there is no limit to the types of checks that you can perform. One of the things that Access Server has, which also plays into identity-based access, is that it supports mixed authentication. What I mean by that is that you can configure all, if you want, all the uh, authentication methods that I mentioned, and you can set one of those authentication methods to be the default. But you can override that default for specific user groups or even users to some other authentication method that has also been configured. So for example, you can say that all the user groups which are employees will use the default SAML SSO method, but you can override that default uh, by, let's say, some employees have joined your company from an acquisition and they have their legacy LDAP solution for authentication. You can put those new employees in a different user group. And for that user group, you can set LDAP as the authentication method. So again, this lets you use the same access server, same identity based authentication with a mixture of authentication methods. Digging into the type of access control that's allowed, we have 3 tiers of access controls. So you can set ACLs at the global level. So you would typically just give permissions to something that everyone needs. For example, your private DNS server or something like that, ideally. So at the global level, you would be very restrictive and just provide access to applications and IP services that everyone needs. Then at the user group level, you'll be adding access controls for applications that are based on roles or departments or however you define your groups, so that there is group-based least privilege access. And then you can map the user groups configured in Access Server to the groups or any other attribute that's configured in your identity provider that you authenticate with SAML or LDAP or radius against. So that's why the group mapping and group least privilege access is important here. And then if you want to override or not override, if you want to provide additive permissions to a specific user, you can even configure an ACL at the user level. So basically, when a user connects to Access Server, all of these access controls have an additive effect. So the user will get access to everything that's allowed at the global level, is allowed at the user group level, the user group to which that user belongs, and also set for that specific user. Now, I talked about this script. We call it a post-auth script. And the reason it's called post-auth is because it triggers when the user signs in with a VPN client, meaning just before the VPN connection, or when the user logs in to the Access Server portal. Once they do that, they successfully authenticate with their credentials. Then the post-auth script comes into action, and you can use it to create more checks, check more attributes, and then provide a final authentication response, whether the authentication is successful or not. So the post-auth script can also serve as a sole authentication method. So let's say you don't want to use SAML or LDAP. You just want to create your own authentication method from scratch. You can do that as well. And we have very detailed tutorials and instructions on how to do that. But we do not help or develop these scripts for you, nor can we support scripts that you have developed. We do have some scripts that we provide, and those scripts are supported. So one of the things that this post-auth scripting allows you to do is also allows you to interact with external systems. So you can make API calls to your mobile device management systems to figure out if a device is enrolled in it, to your antivirus systems, or whatever else external security tools you have that would give you a better context on whether to approve or deny this VPN connection. Can be integrated using post-auth. So some of the important scripts for which we have very exhaustive tutorials and for which we support the Python script. So if you have any questions or problems with it, you can contact our support team. We have a post-auth script that will restrict access to only approved devices, that will restrict access to only approved IP addresses. And like I mentioned, the group mapping. So after the LDAP authentication, you can use these post-auth scripts to take that, take one of the LDAP attributes and then map it to the user group that's configured within Access Server. And let's say you have uh, a need for creating a post-auth script. We do have partners that will create post-auth scripts for you and will support that post-auth script. So essentially, this opens up zero trust for you, and you can build any controls that you need. But a point to remember here is that these checks are done only during authentication. So, like the zero trust principle of continuously verify um, it cannot be done right now with the post auth method. But that is part of our roadmap. So device posture checks and other zero trust features and controls without post auth is one of our roadmap feature. Another feature is we are going to completely redo the admin UI, and we are going to make it easier to configure and to see the hierarchy of all the access controls that have been set up for a specific user. So with this interesting future work ahead for us, with this last topic, I hand it over to Sean for the demo. Sean, before the demo, are there any questions you want to address? Any questions?
No, actually, I'm going to share my screen right now, but while I'm doing this, there are a couple of questions about the device posture check as far as the operating system and AV. I don't know if you or Brandon want to address that here live right now before we continue with the demo.
Yeah, so device posture check is in the roadmap. So access, whether an antivirus is running, whether the disk is encrypted, operating system versions, all of those, like what is called quote unquote device posture, all of those checks can be done. But not right now. That's what we have in plans for the future. Right now, you are limited to using the post auth script, which right now the one we supply is based on the UUID that the device sends. So it's more like device identity. It's not device posture. Brandon, you have anything to add?
Yes, about that, we have a post authentication script that we provide as an example that is called host checker. It is basically, it performs a basic check. For example, if an antivirus is installed in the system, but it doesn't provide a really powerful measure to see that, for example, if the antivirus is running, it's just like a filter by the name. If the file exists, uh, that that's the thing that we have right now. And about, can we restrict client devices by operating system versions? Yes. Via post authentication script, you can create an script to, for example, if you want to allow only Windows 11 users to connect to the VPN, or for example, if you only want Windows or Mac OS users to connect to the VPN. And for example, if you attempt to connect using an Android device or an iOS device, you won't be able to do that.
But
Great.
Brandon, these things that you mentioned, do we have post auth scripts available for operating systems, version checks, or is this something that they would need to develop?
No, that's something that the customer will need to develop.
Right. So just
But
just a
we have,
clarification.
yes, but we have an example. For example, we currently have a Mac post authentication scripts with performs a check if the MAC address of the client is allowed or denied. So in that case, you can take that MAC post authentication script as an example and
Right.
modify it as you will. And instead of using a MAC address, use for example, the operating system
Was
of the client.
right. So the information on our website provides all the attributes that are being sent in that hook. So all the attributes that your post auth script can get. So based on that, you can configure your script the way you like and test and check what you want from there. As long as that information gets transferred, your post auth script can get hold of it and can do whatever checks are required by your logic. Also, one thing to note is that only one post auth script can be run at a time. So if, for example, you want to use some of the scripts that we provide and some scripts that you are creating, you would need to combine all of them into one post auth script properly. All right.
Okay, good. Thank you. Thank you both. So we can go ahead and let me share my screen. I think it is shared. Here we go.
Let me log in here. Okay, here we go. So so if we look at the core idea behind ZTNA, every access attempt needs to be verified and clear policies should be in place for every user and device. So the very first step is to identify which application and resources need to be protected and which user groups need access. With that in mind, we're looking at our access server portal or admin user interface right now. And what we're going to do, we're going to set up the authentication method first. So if I go to authentication and settings, we can see right now the local authentication system is set as a default. Now, if we have LDAP or SAML, if we were using something like Microsoft Entra ID, we could set up our SAML. Or if we have Active Directory, we could set up our LDAP. So we need to choose our preferred authentication method, whether SAML, Radius, or LDAP. Then we need to configure the identity provider details, like the metadata URLs and callback settings and so on. So if I go, for example, to SAML, we can see the information that we need to configure SAML for our environment. Now, again, as I mentioned earlier, if we don't have an external IDP provider like Entra ID or Active Directory, there's no issue. We can always use a local authentication method instead. This is the default settings when you install the access server. Now, to make our setup even more secure, don't forget to enable the multi-factor authentication. Now, this adds another layer of protection by requiring users to verify their identity using a second factor like a mobile app. Once the authentication is set, then it's time to create user groups and define their access policies and so on, like support, accounting, finance, HR, and so on. And in order to do so, we can just go to user management and we got the user groups or group permissions here. So once you click on group permissions, you can see I already have a few groups here. But if you want to create another group, you can just click on the box that says new group, and you can just type the group name, such as marketing, for example. And then if you click on more settings, then we can configure this group. So as you can see in Access Server, we can have different authentication methods. We can have it at the system level, like I showed you a second ago. We can have it as a group level here. This is the second way of doing it. And we can have it at the user level as well. We're going to see it in a second. So again, if we had LDAP radius or SAML enabled, we could choose any of those authentication method for our group here. Then if we want to enable or disable multi-factor authentication, now if it's enabled at the system level, then the default is going to be enabled. If not, then we can enable it or disable it here. Also, I want to add that for each group, you can assign specific access policies to control which resources and applications they can access. You can even set restrictions such as defining allowed IP ranges to further secure the environment. So for example, if I want to have this group access only one of my servers, I can just type the address for that server here and then save the settings and then update running server. So now if I go to marketing, we can see that marketing has access to this resource. And then obviously after this, you can create your users. And as you can see, I already have some users here. Now let's talk about enhancing zero trust with post-authentication scripts. This is a pretty nifty tricks that you can do on Access Server to make it more secure. Now, if you go to openvpn.net to our website, and let's just search here for post-auth, let's do post-auth, and you're going to see here that there is a page that says post-auth programming notes and examples. So if you click on this, you can see a good amount of information about post-auth script. So to really boost your zero trust strategy, Access Server allows you to automate access control decisions using post-auth scripts. These are just the Python scripts that you can install on your Access Server. This means that you can set dynamic rules to automatically adjust permissions based on a number of factors after the user logs in. Like if you look at down here, we can see some of examples, hardware address registrations, group mapping, and so on. Like for example, with the group mapping, automating group mapping for SAML, LDAP, or radius, with this post-auth script, you can automatically assign users to specific groups based on their directory attributes when they log in via SAML, LDAP, or radius. Basically, the post-auth reads the user's attributes from the authentication response and then map the user to a specific access server group automatically. If I look up here, we can see the hardware address registration. This is enforcing device-based identity verification. So post-auth script captures the device's UUID or MAC address, and then from then on, users have to use that authorized device, otherwise they won't be able to access. You may ask why this is useful, because even if a user's login credentials are compromised, unauthorized devices won't be able to connect. And basically, this is how you make your zero trust stronger, by requiring both user and device identity. Now, the last one I'm going to talk about here, and this is what we're going to use for our example during this demo, is implementing location-based zero trust access, basically restricting by IP address. We can restrict access based on the IP location, which blocks logins from unknown or untrusted locations. And here's how it works. The post-auth script stores known safe IP addresses for each user, and then if the login attempts comes from an unrecognized IP, the connection is denied or flagged. So let's do this. I'm going to click on this link that says the tutorial. Now, if we look at the steps here, there is obviously there are prerequisites. We want to make sure that we already have those, and then explains about the script a little bit and how to install and update the script. Now, keep in mind that when we do run this script, by default, the way that the script is right now is the very first time the user logs in is going to learn that user's IP address. It's going to register it, and from then on, every time users logs in, they have to use the same IP address. Otherwise, they won't be able to log in. Now, we can change that script any way we want it. That we can just put the IP address in the script, and then from get-go, the user has to be on that location before they can connect. So let's Let's go ahead and look at this. So I already have an SSH session going on. So what I'm going to do, I'm just going to do a side-by-side window so we can see both the instructions and my terminal here. So the very first step is basically we have to retrieve the example Python script. So I'm just going to copy this command and pretty simple, paste it here. Oh, let me elevate my privileges here, and now we're going to do this. And here we go. So this is done. Then the second step, we want to edit our Python script. So we can use any editor. I'm just going to use Nano here. Let's look at this for a second. So if we scroll down here and look at the script, we can see in this script that the user logs in with the username. The client IP addresses gets registered on the first attempt. It does save the IP address, and then from then on, that's the one that's going to verify. So if the client logs in and it's not the first time logging in, it's going to check the username, the IP address, and if the IP address doesn't match with the one that's registered, then the connection gets denied. So we're going to leave it as is, the way it is, but if you know enough Python and you want to make any changes or edit it, you can do that here. So let's go ahead and get out of here. And we're going to go back to side by side. Now, when you make any changes to the scripts, you have to load the scripts into the Access server. Even though we didn't do anything, I'm just going to copy it and do it again. So we're going to reload this script here. Now it's time to test. If you remember, if I go back here to my Access server, I have a user, Kevin. So let's go ahead connect with Kevin from one of our machines first. So let's go ahead connect as Kevin. As you can see, I'm connected to another machine, and we already have Kevin's profile imported into this Connect app. So I'm just going to go toggle the switch, enter the password, and we are connected. So this is the first time we're connecting with Kevin's account after we installed this script. So now the Access server registered this IP address. So if Kevin tries to connect from another machine, he won't be able to. So let's go ahead and disconnect from here. I'm going to confirm and minimize this. So now we're going to try to connect with Kevin from this computer, the one that I'm connected right now. Let's go ahead and create a profile for him. This is the IP address, and we're going to accept this. So Kevin, and then the password. And here we go. So let's go ahead and import it. Now we imported the profile in another computer. So let's go ahead and connect. And we're going to type his password. And here we go. As you can see, the authentication failed. Now the IP address reported by this VPN client does not match the registered IP address. That's the IP address that we got from the other machine very first time when Kevin logged in. So you may ask why this is important. Obviously, it prevents unauthorized access from suspicious locations and helps mitigate phishing attacks, where attackers might try to log in from new untrusted locations. When we're talking about this post-auth scripts, remember Access server only allows loading one post-auth script at a time. So if you need multiple functions like group mapping, hardware registration, and IP location checks, you'll need to combine them into a single Python script. And you have to make sure that to structure the logic properly to ensure all functions execute correctly. So again, I highly recommend you go ahead and look at this page, check out these options that you have with the post-auth scripts, especially when it comes to hardware address registration, group mappings, and restriction by IP addresses. These are really important if you're trying to create a zero trust or ZTNA framework around your network. With that said, I think I can turn it back to Rohit right now.
So this is the input that the post-auth script gets. And again, all of this is documented on our documentation site. So like here's the client information. As Brandon was saying, you can use this platform string, and it has Windows, Mac, Linux, iOS, Android. There's a specific version of client platform. So any of these things that are being input through the script can be used for your zero trust logic. And like I said, you can also use this script to interface with external systems that might have more information about the user's device and context, and bring that into your authentication decision making. So with that, it brings us to the conclusion of this webinar. I don't see any more questions here. And hopefully this has given you a good basis on how to use identity-based access control and some of the post-auth scripts that we have available to strengthen your security posture and to use zero trust checks in your environment. All right. Thank you, Brandon, for joining us and giving your expertise.
No problem, guys.
Okay, thank you, everyone. Oh, there are Q&A. I just saw some coming in. Can clipboard copy and paste be controlled? Preventing files copy? No, because that does not have anything to do with the VPN connection. It's an application level thing. So I don't know from which application you want to prevent it or not. All right. Thank you, Jay. Thank you, everyone.